Hello and welcome back to our video series on data science model selection. My name is David Little. I'm with the Unit for Data Science and Analytics at Arizona State University Library, and we're excited to get started today. So in our previous video, we talked about how do we select our objective, how do we know what we're trying to accomplish, what does our output need to look like? And from that, we move on to figuring out, okay, what kind of algorithm, what kind of analysis technique do I need to choose in order to complete that objective that you've already identified? If you've never been involved in data science before, or, even if you are a data scientist, sometimes the amount of algorithms out there that are available is just overwhelming. There's thousands of them, and there's new ones being developed all the time. Don't feel like you have to know all of them. That's impossible. We have many options within each of these main categories to choose from. So we've got regression, classification, clustering. Within regression, there's plenty of different options here. You've got general regression, you've got logistic regression, you've got generalized linear models, which is very theoretical. You can apply lots of different mathematical functions to it. It can be a lot. With classification, there's even a broader range of different algorithms to choose from that have very different, unique approaches. Things like decision trees, random forests, which is an extension of decision trees. We've got support vector machines, lots of options again. Clustering, we've got some, k-means, nearest neighbors, hierarchical clustering. Those are all examples of each of those. It's really difficult to capture what all the different options are. But I did want to ask another question here. Where would neural networks fit between regression, classification, and clustering? So, I'll give some time to think, but really the answer is a neural network could fit really into any of those categories. So you can take one sort of broad technique or algorithm and tweak it so it will perform all these different objectives. It's one technique or a main technique idea, and it can serve several purposes. Okay, I've got all these options. I know I want to do some sort of regression, but linear, logistic, I don't really know. Well, research will be your best friend in this case. And of course, experience and practice, but that comes with time, especially if you're just first starting. But even now, as a data scientist who does this on a day-to-day basis, I'm constantly looking up, I'm Googling, Stack Exchanging, looking up all the resources, specifically going to each of these packages and looking up the actual documentation that these people have written up for their algorithms and reading through how that works. And again, it's really impossible to know everything there is, and that's okay. Just research, research, research. And don't be afraid to explore. That is part of being a scientist. You've got a question you don't have an answer to, and you gotta look around and see what other ways of answering that question you can find. So the most important thing here is the ability to think through problems and to test the different solutions. And that is much, much more useful of a skill than just memorizing all these different algorithms and memorizing all their different use cases. Another big thing is just don't be afraid to try things out and get your hands dirty. Errors are okay. Maybe you tried a linear algorithm and you get an error and you go, oh wait, I didn't want to use that because I needed a decision tree instead. Don't be afraid to get your hands dirty and try different things out. And I think that about sums it for today. Thank you guys so much. Looking forward to see you in the next video.